All right, we are skipping the pleasantries today because, frankly, you're leaving marks on the table. Look, I know you're putting in the hours, you're memorizing the textbook, but when it comes to the Cambridge Biology 9700 exam, and specifically the Hybridoma method, something is just misfiring. Well, in today's explainer, we're fixing that. We are going to completely rewire your approach using the exact data and strategies straight from Cambridge Principal Examiner reports.
15%. That single number is exactly why we're here right now. Did you know that the Hybridoma method accounts for approximately 15% of the total marks in Paper 2? That is a massive chunk of your final grade sitting in one highly technical area. This isn't just some minor topic you can gloss over. This is literally a make-or-break battleground for your A-level. The stakes are incredibly high, and how you tackle the data and problem-solving here, it's going to echo through your entire result.
So, which brings us to the most painful hurdle, right? Why is interpreting complex data and graphs in this section so impossibly hard? You look at a stimulus showing cell fusion rates, and suddenly your mind just goes completely blank. But here's the secret. The solution doesn't lie in reading the textbook again. No way. The solution actually lies in a very specific examiner framework. There's a precise method to decoding these questions, and I'm going to walk you right through it.
Okay, let's get into Section 1, Core Principles of Hybridomas.
This brings us to theoretical architecture. Think of it like building a house, right? You absolutely cannot put on the roof without a solid foundation. And this foundation rests on precise definitions, causal relationships, and cross-topic integration. Top-performing candidates don't just memorize the steps of fusing a myeloma cell with a spleen cell, they understand the why. They understand what causes what. And crucially, they can take this conceptual understanding and transfer it directly to completely unfamiliar experimental setups in the exam.
And here's exactly what the graders are actively hunting for. Straight from the Principal Examiner report, candidates referencing cross-topic connections achieve significantly higher marks. They want analytical depth, guys, not just superficial breadth. Now, in a minute, I'm going to reveal the ultimate examiner trap that should change how you write every single answer. It's a clue that trips up thousands of students. But before we get to that critical warning, you first need the actionable framework that makes that clue obvious.
Which takes us to Section 2, Mastering Technical Methodology. Let's break down the actual steps.
Whenever you tackle an exam question on the Hybridoma method, you have got to follow a systematic, 5-step procedural framework. Step 1, deconstruct the question to find the command words. Step 2, extract relevant data from the stimulus materials. So don't just summarize it, pull out the exact numbers you need. Step 3, select your analytical framework. Step 4, execute your working with crystal clear notation so the examiner can actually follow your logic. And finally, Step 5, present the final answer using correct, specific terminology. Examiners actively award marks for seeing the systematic process play out on the page.
Let's cut through the confusion of statistical analysis, which I know can sometimes feel kind of like throwing darts blindfolded. When you're analyzing hybridoma data, you absolutely must choose your test correctly. You're going to use the t-test when you're comparing means between two sets of data. You use chi-squared when you're dealing with categorical data. And you rely on correlation tests when you're evaluating relationships between different continuous variables. Memorize this. Applying the wrong statistical framework completely invalidates your analytical depth in the eyes of the examiner.
Beyond the math, there's the whole practical investigation side of things. Data interpretation relies heavily on your experimental skills. You need to know how to select the appropriate apparatus for monoclonal antibody production, follow sequential instructions logically, make highly accurate observations, and record that data in suitable, well-labeled tables. But most importantly, you have to be able to identify anomalies in a given dataset and draw strictly evidence-based conclusions. If your conclusion isn't backed by the data, well, it earns 0 marks, plain and simple.
Moving right along to Section 3, Solving Complex Exam Problems.
Listen, this is the literal difference between a C grade and an A-star grade. A flawed answer simply lists features of monoclonal antibodies. It reads like a sterile textbook index, completely devoid of connection. But the improved top band answer, it performed a true comparative analysis. It identifies similarities and differences. It uses explicit comparative connectives like whereas or conversely, and it supports every single comparison with specific evidence from the data before finally drawing a conclusion about their relative importance. That is the level of depth required.
To reliably produce that top band answer, you really have to internalize this problem-solving sequence. Deconstruct, solve, evaluate. But it's this final step that students always skip. Check for reasonability.
If your calculated cell fusion rate or antibody concentration makes zero biological sense, you've made an error in your methodology somewhere. You gotta verify before you move on.
Section 4. Critical warnings from the examiner.
Avoiding these 3 exact mistakes is absolutely crucial. Number 1, using terminology in the wrong context. A word might be biologically correct, but entirely wrong for the specific hybridoma scenario. Number 2, forgetting to check units and terminology in calculations and graphs. This literally throws off everything. And number 3, the most fatal one, providing generic, memorized answers that lack the specific context given in the question stimulus. Examiners despise generic answers. Your response absolutely must be married to the data provided.
And that brings us to the ultimate examiner alert. Candidates consistently confuse key terminology. Always define terms first. Guys, this is the hidden trap. You might write a brilliant, complex explanation of the hybridoma method, but if you fail to define your core terms, your entire foundation crumbles. The examiner cannot just assume you know what the words mean just because you use them. Define the terms first, and then build your argument.
But I want to leave you with a final, really important diagnostic cliffhanger to think about. What happens if you perfect your methodology, you master your terminology, but you completely misread the hidden command words? Yeah, all this strategy completely fails if you don't know the difference between describe, explain, and evaluate. The hidden cause of lost marks almost always comes down to command word confusion. So, to decode those exact words, you'll want to join me in the next explainer. Subscribe to our YouTube channel, Ace the Exams, and I'll see you in the next masterclass.